Hello friends, I am Prashant Vishwanath Dhanshetti, Assistant Professor, Department of Civil Engineering from Walchand Institute of Technology, Solapur. Today I am here to give a brief description about conjugate beam. At the end of this session, the students will be able to construct the conjugate beam and they will be able to understand the procedure to calculate the slope and deflection in the beam member. Slope and deflection by conjugate beam method. So, there is much more importance to calculate the slope and deflection of the beam. So, if a beam carries a uniformly distributed load or a point load, it is deflected from the original position. The amount by which the beam is deflected from its position is very important from the serviceability point of view. See, if we are sitting in a room and the beam above it has bent a lot and there is a lot of deflection in that. So, we are uncomfortable to sit in that room. So, from the serviceability point of view, this deflection calculation and slope calculation is an important factor. So, due to the load acting on the beam, it will be subjected to bending moment. The radius of curvature of the deflected beam is given by this equation. So, this equation is a flexural formula, that is m upon I is equals to E by R. So, the radius of curvature will be constant if R is equals to I into E by M, it is constant. So, see, this is the original position of the beam before loading. So, when you load a point load or a UDL, this will be your position after loading, that is the deflection of the beam will be there. The term E into I by M will be constant if the beam is subjected to constant bending moment M and that will bend in a circular arc. Now, let us consider a beam AB of length L and it is simply supported at A and B and has a point load P at the midpoint of the beam. The beam will be subjected to bending moment and therefore will be bent in the form of a curvature or a circular arc. So, this beam will be bent in the form of a circular arch. Now, what is deflection? So, deflection of the beam is basically defined as the vertical distance of the beam measured before and after loading. The deflection of the beam will be denoted by Y and its unit of measurement will be mm. So, see, this is the original position of the beam and this is the deflected position of the beam. So, this vertical distance before loading and after loading, that is called the deflection, which is termed as Y and it has the measurement unit as mm. Now, what is slope? Slope in the deflection of the beam will be defined as the angle turned by the beam under the action of the load and hence under the action of bending moment. So, due to this load, this beam will bend and this has been turned by an angle, this theta, that is the slope of that beam. The slope and deflection of the beam may be obtained from various methods like double integration method, Macaulay's method, moment area method, etc. But this method becomes laborious when applied to the beam whose flexural rigidity, that is the product of E and I, is not uniform throughout the length of the beam. So, if there is a change in the section of the beam, then it is very laborious work to find the slope and deflection using this method. But the slope and deflection of such beams which has variable sections can be easily obtained by conjugate beam method. Now, the conjugate beam method is the method used to determine the slope and deflection of the beam. In this method, an imaginary conjugate beam is constructed from the real beam and the shear force and bending moment of the conjugate beams are equal to slope and deflection of the real beam. So, what is a real beam? The real beam is the one with actual loads and support, and conjugate beam, it is an imaginary beam which is having length equal to that of original beam, but for which the loading diagram is m divided by EI diagram, that is the load at any point on the conjugate beam is equal to bending moment at that point divided by EI. So, now to draw the conjugate beam, it is necessary to know the conversion of the support from the real beam to conjugate beam. So, here is a table which shows the conversion of the supports. So, actual beam and conjugate beam. So, if in actual beam the support are simply supported or roller supported, so in conjugate beam they will be treated as simply supported end. So, here as this deflection is correlated to the bending moment and slope is correlated to shear force. So, we can see that in actual beam the deflection is 0 for simply supported or roller support, whereas in simple support bending moment is 0. But slope exists in simple support and roller support of actual beam, hence shear force exists for a simple support end in conjugate beam. So, these are correlated. Deflection is related to bending moment and slope is related to shear force. Then free end will be changed to fixed end in a conjugate beam, as in free end of actual beam slope and deflection exist, whereas shear force and bending moment exist in the conjugate beam. Now, fixed end in the actual beam will be converted to free end in the conjugate beam, as in actual beam for the fixed end slope and deflections are 0, hence it is converted to free end in the conjugate beam where shear force and bending moment are 0. Then slope at any section in actual beam is equals to shear force at the corresponding section. Then deflection at any section is equal to bending moment at the corresponding section. For a given system of loading in actual beam, the loading in the conjugate beam will be M upon EI diagram. Then bending moment diagram, if it is positive in the actual beam, that is sagging, then M upon EI loading diagram is positive, that is the loading is downward in case of conjugate beam. If the bending moment diagram is negative, that is hogging in case of actual beam, then M upon EI diagram is negative, that is loading is upward in case of conjugate beam. Now, we will see the steps how to draw the conjugate beam from a real beam. First, draw the bending moment diagram for the real beam. So, you calculate the bending moment at various points for real beam. Divide the magnitudes of the bending moment by flexural rigidity and draw M by EI diagram. Then draw a conjugate beam having the same length as that of real beam. Plot the loading same as M upon EI diagram as we have seen in this step 2. Then apply the support to the conjugate diagram as described in the previous slide. Now, mention the conversion of fixed support done while drawing the conjugate beam. Here pause the video and try to write the answer on a paper. The fixed end in the real beam is converted to free end in the conjugate beam. Now, let us try to draw a conjugate beam. So, draw a conjugate beam for a cantilever having point load P 500 Newton. So, this P is 500 Newton and it is acting at the center. So, 2 meter AB and BC will be 2 meter. So, now first of all I will find out the reactions. So, reaction taking summation of Fy is equals to 0. So, only downward force is P, that is 500 Newton, and this reaction will be upward Ra. So, Ra minus 500 is 0, therefore, Ra, that is reaction, is 500 Newton upward. And the bending moment. So, when we take the bending moment, that is, see, if we start from this point C, there is no load considering the right of the section. So, there is no load up to B point. So there will be no bending moment or shear force. So when we come from B to A, the bending moment goes on increasing, as bending moment is the product of force into distance. So the bending moment at A will be this load into the distance of this load from A. So P is 500 and distance is 2. So that will be 1000 Newton meter. So this will be 1000 Newton meter. So now this will be anti-clockwise, because see, P is producing a clockwise moment. To counteract, we will have at the support anti-clockwise moment. So this is minus 1000 Newton meter. So now, as it is a hogging bending moment, so that is negative. Now we have to draw the loading diagram, that is M upon EI diagram. So there, this is M upon EI diagram. So bending moment is 1000 divided by EI. Now we will form a conjugate beam. So now the free end is converted to fixed end and fixed end is converted to free end. See, at A it is fixed in the real beam and free in the conjugate beam, whereas C point is free in the real beam and it is fixed in the conjugate beam. And as the bending moment is negative hogging, so the load will be acting upwards. So this is minus 1000 divided by EI. So this is the conjugate beam diagram for this real beam as shown here. So these are the references which I have referred. Thank you. Thank you very much for watching my video.